All right, so we're gonna go ahead. We're a little behind schedule, so I want to make sure I make good use of time and stuff. So, this past Tuesday we talked about uh, value returning functions, right? We wrote a little program together using value returning functions, and so we're going to continue that today. We're going to look at a new concept called reference parameters. Okay, so just kind of there might have been a couple of people who weren't here on Tuesday, so let's just kind of review a little bit. So these were the concepts that we were talking about, right? First of all, what is a function? A function is just a self-contained module of code that accomplishes some task, right? So it's a way of splitting up your program into smaller pieces, into kind of self-contained modules, right? We said that there's some functions that have already been written for us, right? Those are predefined functions, and we can use those, but we have to know a couple of things and do a couple of things. We need to know the header file that contains that predefined function that we want to use, and we need to include that. So you're going to have a line of code up towards the top with all your include files and stuff, where you include that header file. You also need to know a little bit about how to use it. So how to use that predefined function. So if there's a function, if you're supposed to send in two parameters, like the power function, for example, if you're expected to send in two things, you have to know that, right? And you have to know that the first one is the base and the second parameter is the exponent. And if it's a value returning function, you need to know that as well, so you can do something with that return value. All right, and then we start talking about user-defined functions. Those are functions that you as a programmer write. And so that's what we're going to be spending most of our time doing in this chapter. And so we talked about kind of two general categories, I guess you could say. You could have a value returning function. A value returning function is a function that's going to have a statement in there, usually the last statement in the function that says return and then something, right? And so it returns something to the function that calls it, right? We said there's one limitation, one of the main limitations with value returning functions is that you can only return one value, right? So you can only return one value. You can't return multiple things with a return statement. Okay? If it's not a value returning function, then it's a void function. A void function is just a function that doesn't return anything. It's not going to have a return statement there in it. Okay. All right, and then we talked about this concept of parameters. Remember, parameters are any kind of input that you send into the functions, into your function, right? You can send as many parameters as you want to into a function as you need to, and the parameters go inside of parentheses, right? And so you make a list. You put like data type and then parameter name, comma, data type, parameter name, comma, so forth. A couple of other terms we mentioned. The difference between a formal parameter and an actual parameter or actual argument. The formal parameter, that's the name of the parameter down in the function heading, in the actual function with the function definition, right? Those are the names of the parameters down there. And then actual parameter or actual argument, those are the names in the function calls. So and a lot of times I'll just call them parameters and I don't really specify which is which. But if you see those definitions or those terms someplace, that's what that is. Then we talked about kind of the main things that we're going to have when we write our own functions. You're going to have, I'll do the definition first. The function definition, that's all the real code for the function, right? And so that's going to be outside of all other functions. The first line of the function definition is the function heading, and the function heading is going to contain the data type of the return value. So if it returns a double, it's going to start with double. If it returns an int, it's going to start with int. If it's a void function, it's going to have the word void there instead, right? So you have the return type, the name of the function, right? And that function name has to be a valid identifier name. It can only have letters, digits, and underscores. And you shouldn't make it the same as one of your variables, right? Because that could cause you some problems as well. And then after the function name, inside of parentheses, you have your parameter list. Okay? So that's the function heading. Then right after that, you have open and close curly brackets, and all the code for the function, or the body of the function body, goes inside of curly brackets. So the heading and the body together comprise the definition. All right. And then the other two things you'll have a function prototype. They'll usually go towards the top of your program. The function prototypes, I usually put mine after my include files and after any constants that I've declared, but before the main function. That's where I'll put those. A function prototype is you think of that as like a declaration for your function. So the function prototype pretty much looks exactly like the function heading, just with a semicolon after it. And it has to be the same and consistent with the function heading, right? So in other words, if your function heading says that you're going to return a double, your prototype needs to say that it returns a double as well. If your function heading says that the function is going to have 3 parameters, and those parameters are int, double, and string in that order, your prototype needs to say int, double, and string in that same order. Everything's got to be consistent. Okay. So that's the prototype. And then the function call is the line or the statement that's going to make flow of execution skip down to your function definition so that it actually gets done. So you're going to put the function call at the point in which you want it to skip down and execute the function. And so for most of our programs, that's probably going to be inside of our main function. But technically, you could have a function that calls a function, and that function calls another function, and so forth. All right. So those are the things that we talked about on Tuesday. And then we did a little program example together. We rewrote the circle program using value returning functions. And so to see those things, here were our prototypes here, all up there. And then we had each one of those functions, we had a separate function for each one, including a separate one for output results. And then, so those are the function definitions. And then in main, we called each one of those functions like that. All right. So the new stuff for today, this is the main concept. And this is a very important concept for you to know for the rest of the semester and going forward into other courses. There's 2 main ways that we're going to talk about how to pass parameters into functions. Now we said that, I'll do it down here. We said that with value returning functions, one of the main limitations is that you can only return one value. So what if you wanted to write a function that changed a whole bunch of things, right? So over here, what if we wanted to write this circle program so that instead of having a separate calculation function to calculate each thing, because all these were extremely short, right? What if instead we wanted to just write one function that calculated everything, like calc stuff or something like that? So how could we do that? Well, we couldn't just write a value returning function because we can only return one thing, right? But we said we can pass as many parameters as we want to. And so that leads us to this topic. There's two main ways that we're going to talk about how to pass parameters into functions. The first one is how it's done by default. And that is pass by value. Okay? So normally, and how we've done it in our example that we wrote, what happens when you pass a parameter by value is that it actually makes a copy of what the parameter is. It makes a copy of the actual parameter and sends a copy to the function. Okay? And so one thing to note about that is if the copy is changed, it doesn't affect the original back in the calling function. So what we're talking about here are memory concepts, right? Whenever you declare a variable, it reserves memory for it, right? So I can draw you a little picture. Hold on. This is a new little toy that I got. Here, I'll leave that back up. I'll do this. All right, so suppose that you had, like in our program, right? Well, just take output results, for example. Right, we wrote output results. So like over in main, we had our main function. We had all of our variables declared in main. Sorry if my handwriting's bad. It actually looks better on the boogie board than on the screen. So we had like radius, and each one of these had memory reserved for it, right? Diameter, circumference, area, and so forth. Right, you had the sphere ones too, right? Well, like over in output results, we send in all those things, right? We just named them different things like R, D, C, and A, and so forth. And by default, when you send those, it passes them by value. So each one, if there's a box, that means it's got memory reserved for it. So just say, radius was 5, so diameter was 10, and whatever all the others are, right? So it's going to copy those over to here. So that's how it's done by default. So it copies that to that. That's passed by value. Does that make sense? And that's how it's done by default. Right? Now, this other way of passing a parameter that we're going to talk about today is passed by reference. And what happens when you pass a parameter by reference, instead of sending a copy of the parameter, it sends the memory address of where the parameter is stored. Okay? So it sends the memory address of where the original actual parameter is stored. And so the important thing to note about that is if the parameter is changed inside the function, it will also change the original back in the calling function. It refers back to the original one. Okay? And so we could use this to our advantage sometimes. If you want a parameter to be able to change inside the function, you pass it by reference. Here's how you do it. I'll make a note of here. To pass by reference, probably wondering, well, how do you do it? To pass by reference, add an ampersand, that guy, in the parameter list after the data type of the parameter. That's where I put it. It's just got to go someplace between the data type and the parameter name. Right? I usually, and I think the book puts it next to right next to the data type. I think I've seen it actually. Some places will put it right in front of the parameter name. I'll put it with the data type. All right. So, in other words, so what if we wanted to write a function that calculated everything, right? So we wanted it to be the same type of setup. So you had main like that, and so you had all your variables. Like that. Sorry, that's pretty bad. And then over here you want calc stuff, right? So if you send them all over by if you send them by value, if you just send them over like normal, like send them by value, so it'll be sending copies. Suppose you calculate everything over there, and you'll have all your calculations over there in that function. Well, you're going to be changing the copies, right? You won't be changing the originals back in main, and that's no good, because then you're going to send the originals over to output results, and it's going to output zeros or just garbage values or whatever. So you want to pass them by reference so they refer back, except for maybe the radius. The radius, at that point we've already input it, so we already know what it is. So we can pass the radius by value. So we'll copy it over, but then send the other ones by reference so they refer back. So like the diameter, instead of getting its own memory location, it's going to refer back to the diameter back in main, and the circumference, and so forth. Like that. So that when I change them over here in calc stuff, it changes them back in main. That's the idea. Okay? And so it's really easy to do. You just add that ampersand, but you just have to recognize that you need to do it. Right? So you might wonder, well, when should I pass by value? When should I pass by reference? I can't remember if I wrote this down. Yeah. So when to pass by value and when to pass by reference. So this is the general rule of thumb. If the function needs to change the parameter, pass by reference, right? If the function needs to be able to change the parameter, pass by reference. But if the function does not need to change the parameter, it's better to pass by value so that you're not giving the power to change it. Yes?
So if your parameter was like int a, where do you put the ampersand?
You'd say like int ampersand.
Without a space?
I usually do it without a space. Okay. Yeah. But I think technically it doesn't matter. I think you could have int space ampersand space the parameter name. I think as long as it's in there, but I'll put it right to the right of the data type. So int ampersand space in the parameter name. What I do. So technically you could always send all your parameters by reference if you really wanted to, right? But that's not a good programming practice to do, right? So remember this thing I mentioned before, the principle of least privilege, right? I'll come back to that from time to time. Remember what that says? The principle of, did I mention that? Or maybe not. I got 2 sections, so I forget what I say in each section. The principle of least privilege basically states something like, don't give the power or the access to something if it doesn't need it. It's kind of like that old saying, you're on a need to know basis and you don't need to know, right? So if the function needs needs the ability to change the contents of that parameter, then pass it by reference. But if it doesn't, pass it by value. That's the general rule, so that you're not giving the power to be able to change it. Right. Another thing that we've mentioned is global and local variables, right? And we'll talk more about that probably next week. But we'll see that if you declare something globally, that means outside of all blocks of code, outside of all functions, then any function can access that, right? So the natural thought might be, well, why don't you just declare all of your variables outside of main? So declare all your variables globally, then you don't have to pass any parameters to anything, right? Then every function can access every variable, right? But again, that's a bad programming practice as well. It goes against that principle of least privilege thing. You're giving the power to any function to be able to access and change any variable, and that's not a good programming practice. Usually, we usually say it's okay to do it with global constants, because in fact that's what we did with our pi, right? Global constants, because they're constants, they're not allowed to change. You can't change them. So we usually say that that's okay. All right. So does that make sense, that concept? Right. So if you pass by value, you are sending a copy. If you pass by reference, you're sending the memory address, and it refers back. So, yeah, so to pass by reference, all you have to do is add an ampersand in the parameter list after the data type of the parameter. And that ampersand has to go in the heading and the prototype. But in the call, you don't do anything different. You just list the names. So how about we do an example? So do you guys have your code that we did on Tuesday? It'll be easier if we can start off with that, so we don't have to type everything from scratch again. I'm going to redo this.